Welcome viewers to the SD online classes. This is class 10 MBSc Physics chapter 2, the human eye and the colorful world. We have done before some of the things in this chapter, like human eye we have described all, and after that what are the human eye deficiencies we have, so those were discussed, okay, and according to them what are the lenses required, those requiring the concave and the convex lens, and depending on them the numericals were also solved till the video number 14 of the chapter 2. Today we will be starting a slightly new topic in the same chapter. It is prism. Okay, prism is the topic that we are going to start today. So let me draw the diagram and try to make you understand what it is. So you look at the diagram and try to understand. A prism is a medium bound. Bound means surrounded by. Here this side is air, this side is air. The between is the prism, actually is the glass. Okay, but in real prism may not be a glass. It can be some other medium also. It can be made out of anything, like it can be made with water also. You can make the ice prism also. You can make a prism of some honey also. You can make of any other liquid also, or any other gas also you can make. So it is, that is why it is defined very generally. Okay, a medium bound by two plane refracting surface. This is the surface, this side is the surface. Okay, it is like this side is the surface and this side is the other surface. Okay, like this, right, triangulation, and then this side and this side will be surface. You can see it is a three-dimensional diagram, so that is why the dotted line means behind. This dotted is behind, front you can see like this. Okay, the edges are A, B, C. From the front side if you look, it will look like a triangle. On the back side also you look, it will look like another triangle. So sidewise you will find this way. If you see, make it down from the bottom side. If you see the bottom side, the view will be, it is there in your textbook, page number 55, you can see there also. From the bottom side if you look, your diagram will look somewhat like this. You can imagine. Okay, the best thing is to imagine the thing when you tilt it. If you make it down, if you make it stand on that back side, right now which is back side, if you make it into the downside, you will look that this is the floor. Now it is facing towards your face. Okay, this is actually floor here, this ground. B, C, F, E is now this side. Okay, this is A, this is B, this is C, this is F, this is E, this is D. You can understand? So this is the prism, you can understand very clearly. And in rough diagrams, whenever we are doing some calculation, we don't need to make the whole prism. We only write like this and we say it is the prism. Behind it, there is the whole thing. This is the rough way of drawing a prism. If you draw like this, it is understood that you are drawing a prism. Now in the prism, this distance is called base. Why base? Because it is sitting on the base. Okay, and this side, from this side, you can see from this side on this wall, A, B, E, D, this wall, A, B, E, D, left wall, that is only represented by AB. Okay, this is the refracting surface. This is the angle of prism. How big or how small is the wideness here, defined by this refracting angle. It is written here also. Okay, refracting angle, and this is also refracting surface. This diagram and this diagram is same. Here we don't need to show this time, that's all. Okay, so this is the prism. You have understood its meaning. Now prism has A, very important. This A is important. This is called angle of prism. Okay, A is called angle of prism. So that is called a refracting angle also. Okay, and base you should understand, both side, this side and this side is a refracting surface. Now why did we study this? Because we want to see when we pass the light what it will do. Earlier we have already finished convex lens, concave lens, everything. So this is also a refracting medium. So what it will happen when light enters here? So that is interesting. That is why we are going to study this prism as a new topic in our refracting media. Okay, so let us see the next topic here. Now let us see how it behaves when the light is passing through the prism. This I have made a prism. To see, there is an activity 2.1 in page number, activity 2.1 in page number 56. This is that one. Okay, it is also an experiment in class 10, even in class 11, 12 also. To see how the light ray when it passes through the prism, that this type of prism, but we show only this type of prism here, to get refracted through a triangle glass prism. Triangular means because it looks like triangle, so it is a triangular prism. So now what will happen, I will take a small scale. Suppose this is the light entering. There are of course many lights are entering, okay, but we will take only one light for our study. Suppose this is the light which is entering. We call this light PQ. Okay, PQ is going from here. Now when it enters from this wall, okay, this is the wall. When it enters this wall, you have to apply your previous knowledge that suppose this is the perpendicular. This is called normal. Okay, this is the rarer medium. Air is the rarer medium, glass is the denser medium. Air is the rarer medium, this is the denser medium. Okay, now when it goes from rarer to denser, the light should bend towards the normal. Towards means it is going like this, but when it is entering in the glass, it will go like this, in this, towards this normal. Where is the normal? Normal is this dotted line. So if it is going like this, it will move like this. Okay, that is the rule of your refraction. So now that means this light will go now inside the prism, it will go like this. So inside it will be straight, but when it is about to go out, again the rule with that normal will be decided. Again this is the imaginary normal line. Normal means perpendicular line. From here, denser to rarer medium. Again, when light enters from denser to rarer medium, it will bend away from the normal. Away from the normal means in real it should go like this straight, but it will go away from the normal. Because this is the normal, it will go away from the normal. Okay, so this away is like this. It is up to you how much away you want to make. Okay, so this way PQ is entering, and the point where it entered is E, the point where it came out is F. It is up to you, whatever you want you can make it. Okay, and then here this is the normal N, this is N dash, just the name of the normal line. This is M dash, that perpendicular imaginary line, that is why it is written in dotted form. Now the most important thing is, when the light was initially going like this, after entering here, where it is going upward, but after entering and coming out, it is going downside. You can see it was going like this, but we have found that the light is going downside now in this direction, isn't it? So how much it has turned, that we have to find. How much it has turned is found like this. You make retrace their path. How? Okay, don't confuse with the other lines. This one also retrace back. Okay, so now you see it was going here, this much is the turn. Can you see? It was going like this. Okay, with the help of a refill I can show you. It was going like this. Okay, but now it is going like this. Okay, that means how much is the turn? The turn is the angle, this much. What is that angle? That angle is this angle. This is called deviation. Deviation means how much it has changed its angle. Okay, that is written as D. Okay, D, angle D. This point where it is calculated is G, right? So everything finished now. So only the simple things remain. This is called angle of incidence, this is called angle of refraction, okay, and this is called angle of emergence. Emergence means going out, okay. So these are the things we have to understand, and we have seen what? To see how means all these things. Light rays get refracted. Refraction is this one. What it happened? It bent. Light bending is called refraction through a triangular prism. This is a triangular prism. So this is what it happened, okay. And when you are asked, you should be able to tell your friends or to others how it happened inside, why it turned this side, why it turned this side, and how it has finally gone. This is important to show the direction also. You can give some name S. So this is how the prism, everything has happened, okay. And some relations are also there. The relations are what? I'll write in the next page. Let me redraw the diagram quickly to make you understand again. This is the prism. P, Q at E, refracted somewhat this much, and then next this much. Here was the normal line. When you practice more, you can easily draw like this, okay. It is not difficult at all. Even without looking also you can do. And what is the deviation? This much. This much is the deviation. This was D. Why D? Because it was division. You remember this was G, this was A, this was B, this was C, okay. And last one is here, it is F, so it is E, it is F here. The outgoing is R S, just like PQ, RS is going, PQ, RS going out, like that you can remember, okay. And D deviation, everything is done. So here ABC is the prism, fine. PQ is the light ray, AB is the first refracting surface, air is the rarer medium, here and here air, denser medium is the glass inside, EF is the inside refracted ray after refraction from AB. After refracting from AB, the light is EF, okay. I should give the direction also. And then after AC, it will come out RS. That is all it happened, okay. Now what is simple thing I have to write here is angle I plus angle E, emergent angle. This was emergent angle, this was angle I, this was angle A, equal to angle A plus angle D. This is a geometrical relation, very simple relation, but it is not in your syllabus to prove, so we will not go into it. So you have to just remember this. I plus E is equal to A plus D. I plus E is equal to A plus D. So this is the simple. The angle of incidence plus angle of emergence equal to angle of prism plus equal to plus angle of deviation, that much, okay. Now angle of deviation is directly proportional to angle of prism. Angle of deviation is directly proportional to angle of prism. If the angle of prism A is very big, okay, then the deviation angle will also be big. Higher the refractive index of the material, if the mu is big, the angle of deviation will be big, okay. Why we are studying angle of deviation? Because the refraction is decided by more or less of the refractive the deviation. If deviation is more, you have high refractive index. So if the wavelength of the light used is longer, then the refractive index of the material of the prism is low. So all this in the next section also we will do, and we will try to understand better, okay. So these are all given in page number 55 and 56. With the help of the diagram and the class, you try to write in your notebook also. Thank you. That is all for this class.